Now everybody knows what a tree is, but the question is, how do you find if something is an AVL tree or not? Look, if I look at this as a set of trees. Now inside of this tree, you're gonna get something called a binary tree. Okay, you're gonna get binary trees, you're gonna get complete trees, you're gonna get different type decision trees, many type of trees. Now a binary tree is a subset of a tree. A subset of binary tree would be a BST. Okay, you know what a BST is, right? BST is that if you have a tree on the if you have a node on the left of that is going to be a smaller number, okay, numbers that are less than the root, and on the right is going to be numbers that are greater than the root. So that's what the BST is. AVL is a subset of BST. So all AVL trees are BST, but not all BST are AVL. Think about that if you don't understand. So when we find out AVL, okay, there's going to be three magic numbers: -1, 0, and 1. These three numbers are our magic numbers to decide if something is AVL or not. So now you're gonna have to find out if something is AVL. So the formula for AVL is that left minus right. You're gonna compare every node inside of a tree and you're gonna apply this formula to it, and if you get -1 or 0 or 1, then it means it's an AVL tree. So let me just quickly draw a node, or actually a tree, sorry. I'm gonna apply this formula to this root node. Okay, left minus right. Left, how many children do I have on the left? I have one child here, so this is gonna be 1. How many children on the right hand side? I have only 1, so I'm gonna -1, so I'm gonna get a 0. So now this 0 is this 0 over here, so meaning that this node is fine. Now I'm gonna apply the same formula over here. How many nodes do I have for this on the left? I have 0. And how many on the right? There is none on the right and there is none on the left, so there's 0, so answer is 0. So this magic number appears again, 0, and same here is going to appear again. So this is in fact an AVL tree, this entire tree. So that's how you judge. It might seem a bit difficult and long in the beginning, but once you do get a bit of practice, you're going to get that it's actually quite simple. So now I'm going to create another node, small, couple other nodes inside of this, maybe like this. Okay, and the way you would consider AVL, you should start at the bottom of the tree. You're not going to start at the root. Okay, that's a bit of bad practice. You're going to start at the root and you're going to go your way, you're going to work your way upwards. So let's start at the root, comparing. Okay, so how many nodes does this have on the left and right? 0, so 0 minus 0 is 0. This is fine. Now you're going to compare here. How many on the left? We have 0 on the left. How many on the right? -1. So 0 minus 1 is -1. So this number appears, so this node is also fine. Okay, now you're going to compare this node over here. Okay, so how many on the left? I have 0, but how many on the right? I have 2. So -2, this is going to give us -2, and this doesn't fall in our -2 is not in our magic numbers list. So meaning that you have a number that is not -1, 0 or 1, then we call that imbalancing. So there is imbalancing that's occurring at this node. There might be occurring at this node as well, or this, actually not there, but we're not going to go there. We just want to find one node where imbalancing occurs, and if there is imbalancing, then this means that this is not an AVL tree. So yeah, that's just simply how to find out if something is AVL or not. Thanks for watching.